Hello everybody, today I will be showing you how to use a breadboard, but first how to create a complete circuit or a simple circuit on a breadboard. But first I will be talking about color codes on a resistor. This is important for you to know because you have to use the right resistor when you create a circuit. So this diagram you see on the left is a resistor color code, and you see various different colors. Black, you see on the rows you see first band, second band, third band multiplier, fourth band tolerance. So the way you read, the way you interpret or determine the number of ohms a resistor has by looking at the color code on the resistor would be just by let's say the first let's go to the first example. So determine the value of the resistor in ohms for that resistor. So the first color we see here is red. So red is number 2 on the first band. And the next color you see on the second band is black. That is 1. The third band multiplier is the color yellow. So that's 10,000 ohms. Or we could say 10K. And the last band is gold. And the fourth band tolerance for gold is plus or minus 5%. So in this example, the way I do it is red equals 2, second band black equals 0. So red and black is 2 zeros, so 20. So yellow is on the third band is 10,000 K, 10,000 ohms, or 10K ohms. So it'll be 20 times 10,000 ohms equals 200,000 ohms, or 2K ohms. And the last band I said was gold. So it is plus or minus 5%. So it'll be 200,000 ohms at plus or minus 5% for the first example. The second example, determine the value of the ohms resistors in ohms. So the first one I see, first band is green, that is number 5. Second band is blue, that is number 6. Third band is orange, that is 1,000 ohms. And the last band is gold, that is plus or minus 5%. So blue and gold is 5 and 6, so 56. Orange is 1,000 ohms, so that would be 56 times 1,000 ohms is equal to 56,000 ohms, or 5K ohms. So, and this is at 5% because it has a gold band at the end. So this resistor has a value of 56,000 ohms plus or minus 5%. And the last example is this. I have a resistance of 2,000 ohms. That's for the resistor. So what would be the color band of the resistor that I would have to use? Okay, so it would have to equal 2,000 at plus or minus 2%. So the first band should be 2, so that is red. The second band should be black, which is 0. So that would be 20. And we want, so the total ohms that we need is 2,000. So we would divide 2,000 ohms divided by 20. So that would give us 1000 ohms. So orange for the third band has to be orange because it's 1000 ohms, right? So orange, and the last band is plus or minus 2%, so that would have to be red. So the color sequence would be red, black, orange, and red. So that's what the color sequence would have to be for the resistor. Okay, what you see here is a breadboard. So the way you use a breadboard is like this. For the rows, they're not interconnected. You just have to know that. For columns, they are connected as long as they don't pass the trench line, which you see on the blue rectangle. So if you cross the trench line, it's not connected. So each trench line has its own columns of connectors, so they're all different. And as for the rows on the far top or the far bottom, they are connected horizontally or by rows, so all the negatives would be connected together, and all the positives on the row would be connected together, and that would hold true for the top as well as the bottom, the ones that are above the trench and the ones that are below the trench. And the next thing you have to know is about the cathode and the anode on the devices that you're using. So in this example, I'm just going to use a simple LED, but it could be a motor or anything like that as well to put on your breadboard. But to make this is just a simple example, so I'm just going to use a LED. So the cathode side is shorter than the anode side for the LED. So the cathode side, the cathode is negative, and the positive is the anode, the longer side. So you see the simple circuit on the bottom left. That's what I will be recreating on this breadboard. So let's say in my device, the first pin out is positive. But first I would have to connect the resistor, which you see at the bottom. I would connect each ends of the resistor. So the first pin is positive, that's an anode. That would connect to the resistor pin, the same column as a resistor pin on one end. So the blue line connects to that, and then the LED on the anode side is connected to the other end of the resistor pin on the same column as the second side of the resistor pin, and that would be positive. And you would connect the second part of the LED into the breadboard. And the second part just connects, you can connect it anywhere. But the second part of the resistor of the LED must be in the same column as the pin that goes back into your board or whatever on the negative side. So that's how it works basically. And I'm going to show you a video of it so you could see a much clearer picture of it. So on the right diagram, you see the anode pin and you see the resistor pin, they're on the same column, as you can see. And the second side of a resistor pin is connected to the positive part of the LED. And the LED cathode pin is connected to another socket in the breadboard, and that part goes into the cathode of the device that you're using, or the negative part. So that's how it connects. So now I'm going to show you on the next video how it connects, like in relation to how it is. Okay, I'm going to show you next. Okay, so this is a closer look at the breadboard in relation to this device. So this is the Arduino board, and this connector is, I think it's pin 9. It's an anode connector. So this is positive. It connects to this resistor on the same column as here, as you can see. Here's the connector from the device to the resistor, same column right there, and it's connected to another part right there. And this LED is connected to the same column as the resistor at the other end of the leg. And this part, this LED right here, I'm going to show you how it goes in. One side is longer than the other, so the positive side goes in to the second part of the resistor in the same column, of course, right there. I'm going to connect it in here, and this part is called the cathode. This is what goes into the ground. That's what's ground, right? And it's connected to the second leg of the LED, which is right there, as you can see. It's connected in the same column as the second leg, the cathode part of the LED. And this wire goes back into the device, into my Arduino device, into the ground pin, and that's how you make a complete circuit with a breadboard. If you wish to play around with more complicated types of circuits and create them, you would have to know something about Ohm's law and the various types of circuits, like parallel circuits, combination circuits, and stuff like that. And here are a few examples that you can use to calculate that. So I'm just going to go over the basics of what a parallel resistor is, and if you have a parallel resistance, you would of course use Ohm's law, which is V equals voltage equals I is currents in amperes, times R is resistance, and that's in ohms. So for a parallel circuit, the voltage, all the voltages would be equal. So the total voltage V of B is equal to V1, V sub 2, V sub 3. They're all equal to each other. So that's a rule that you have to know. And the currents are all different for each section. And if you want to get the total resistance, it's 1 divided by R sub T, so that's a total resistance. It's equal to divided by 1 divided by R sub 1, that's for the first parallel circuit, and plus divided plus 1 divided by R sub 2, which is another parallel circuit, plus 1 divided by R sub 3, which is the third parallel circuit. And for just a simple circuit like what you see on the right, the rules are as follows. So it's V sub B, so that would be the total voltage, is equal to V sub 1 plus V sub 2 plus V sub 3. So the total voltage must equal to the sum of all the voltages for each resistor. That's what it means. So if you got a total voltage of, let's say you had 100 volts, and all the numbers from V sub 1 to V sub 3 was greater than 100, then the answer is obviously not right. It would have to be equal to that. It can't be less than that. They all have to be equal to that number. So the next rule is the current that flows across that simple circuit is all the same. So if you had, let's say, 5 amperes flowing through that circuit, then it would be the same when it goes across each resistor. It'd be the same thing. So it'd be the same across the board. They would all be equal to each other. And R sub T, that would be the total resistance in ohms. So again, R sub 1 plus R sub 2 plus R sub 3 is all equal to R sub T. So it all be equal to the total resistance. It can't be greater than that. It can't be less than that. Kind of like the voltage rule with that in a simple circuit. So in example 1, what is the resistance if given a current of 3 amps and 5 volts? And this is for a simple circuit, so we would use Ohm's law, which is V equals I times R. The voltage equals the current in amps times the resistance in ohms. So we got 5 volts. So we would have to change the equation around to find the resistance. So it's V equals I times R. So we would have to rearrange it. R equals to voltage divided by ampere. So R equals 5 volts divided by 3 amps. So it's 1.67 ohms. So example 2, given that the resistance R1 is 200 ohms, R2 is 400 ohms, and R3 is 600 ohms. What is the total resistance? This is also for a simple circuit. It's not a parallel circuit, okay? So the rules are as follows. So it's R sub T, the total resistance, is equal to R sub 1 plus R sub 2 plus R sub 3. So we would just add everything together and we would get R sub T. It's like 200 ohms plus 400 ohms plus 600 ohms is equal to 1200 ohms for a simple circuit. So example 3, what is the total voltage given that the current be 3 amps, R3 or resistance 3 being 300 ohms, R2 resistance 2 being 400 ohms, and resistance 1 being 600 ohms. So now we're just going to find the voltage. So we're going to go back to Ohm's law. So it's V equals I times R. So V1 is 3 amps. But like I said for the rules, all the currents are equal to each other. That flows through the circuit. So V sub 1 is 3 amps times 600 ohms. That's 1800 volts. V sub 2 is 3 amps times 400 ohms. That is 1200 volts. V sub 3 is 3 amps times 300 ohms. And that's 900 volts. So V sub t is equal to V sub 1 plus V sub 2 plus V sub 3. So we're just going to add it all together. 1800 volts plus 1200 volts plus 900 volts is 3900 volts. So example 4, we will be dealing with a parallel circuit this time. So given that the total voltage being 5 volts, total current of 2 amps, so I sub 2, the current that flows through the parallel circuit I sub 2 is 1 amp, and the current that flows through I sub 1 is 0.5 amps. What is the total resistance? Okay, well, let's go back to the rules for parallel resistors. It says right there I sub B, which is the total current, is equal to I sub 1 plus I sub 2 plus I sub 3. So we'll write that equation down, and we'll just do this simple algebra. So it's 2 amps, I sub t is 2 amps, is equal to I sub 1, which is 0.5 amps, plus I sub 2, which is 1 amp, plus I sub 3. We're left with I sub 3, and we solve for I sub 3. So I sub 3 is equal to 2 amps minus 0.5 amps minus 1 amp is equal to 0.5 amps. Okay. So when we add all the currents together from I sub 1 to I sub 3, they will all equal to 2. So 0.5 amp plus 0.5 amp plus 1 amp is 2 amps. So that checks out. So the next thing is we want to find the voltage. So we get Ohm's law again. Voltage equals I times R. So the equation for this is 1 divided by R sub t, the total resistance, is equal to 1 divided by R sub 1 plus 1 divided by R sub 2 plus 1 divided by R sub 3. So we would get that equation and write it down. So we need to solve the resistance for each of these from R sub 1 to R sub 3. So we're going to do that. So R sub 1 is, of course, the voltages are all equal to each other. So we have 5 volts divided by I sub 1, which is 0.5 amps. So we get 10 ohms. So R sub 2 is equal to 5 volts divided by I sub 2, which we got as 1 amp, which was given as 1 amp. We get 5 ohms. R sub 3 is equal to the total voltage, which is 5 again, divided by 0.5 amps, which is 10 ohms again. So now we solve the equation. 1 divided by R sub t is equal to 1 divided by R sub 1 plus 1 divided by R sub 2 plus 1 divided by R sub 3. So we just put that into our equation, and we solve for R sub t. So we just do this simple algebra equation and solve it. So 1 divided by R sub t is equal to 1 divided by 10 ohms plus 1 divided by 5 ohms plus 1 divided by 10 ohms. So 1 divided by R sub t is equal to 0.4 ohms. So we get the reciprocal of that. We move R sub t up, and then we move 0.4 ohms down. So we get R sub t is equal to 1 divided by 0.4 ohms. We get 2.5 ohms. And that's it for that. The parallel circuits could be as long as you want to make it. but we just picked 3 sets. So I'll go to the next thing, which will be combination circuits. Okay, in this next thing, I will be discussing combination circuits, and that would be the equation that is all the way to the right, which you see the combination circuit diagram. And in this combination circuit, you have a parallel circuit inside that, inside a regular circuit. Okay. So the rules are as follows. All the currents here, current I, they're all equal to each other. So I sub B is the total current, is equal to I sub 1 plus, is equal to I sub 2 and I sub 3. They're all equal to each other. So all the current that runs through the circuit is the same, in other words. And another rule we have to know here is the total voltage V sub B is equal to 1 times R sub 1, which you see the R sub 1 resistor, which is outside of that parallel circuit, plus, plus 1 I times R2 sub 3. So that would be the circuit. R sub 2 sub 3 is another resistance in that simple circuit. So we have to combine the two together to get R sub 2 2/3. Okay? So let's go through an example. And before I do that, I would have to go back to R sub T. The resistance is equal to R sub 1. The total resistance is equal to R sub 1 plus R divided by 2/3. Okay? And that's what you have to know. So now we're going to just do this simple example, and I'm going to demonstrate how it works. So given that R sub 2 is 300 ohms, R sub 3 is 400 ohms, what is R sub 2/3? So we would use the equation I divided by R 2/3 is equal to 1 divided by R sub 2 plus 1 divided by R sub 3. And that's very similar to the parallel circuit that I was doing before, which you see on the left diagram. That equation is very similar. So let's just plug in the numbers and solve it. So let's just solve this little algebra equation. So it's R, we're going to solve for R 2/3. So R 2/3 goes on the other side, and the parentheses of 1 R sub 2 plus 1 R sub 3. 1 divided by R sub 3 goes on the bottom on the other side. So R sub 2/3 is equal to 1 divided by the parentheses of 1 R sub 2 plus 1 R sub 3 parentheses. So it's 1 divided by parentheses 1 divided by 300 ohms plus 1 divided by 400 ohms is equal to 172.41 ohms. Okay? So that's what we get for R sub 2/3, which is the resistor, which is a combination of the parallel resistor R2 and R3. Let's go to the next example. Example 2. What is the total resistance given that R1 is equal to 500 ohms? So R sub t, the rule here is equal to R sub 1 plus R 2/3. So R sub t is equal to 500 ohms, which which is given, plus R sub 2/3, which I derived in the first example, as 172.41 ohms. So we get a total resistance of 672.41 ohms. And let's go to example 3. What is the total voltage given that the electric current is 2 amps? So again, the rule is that the current that runs through this combo circuit is all the same. They're all equal to each other. So I sub t is equal to I sub 1 is equal to I sub 2 and equal to I sub 3. They're all equal to each other, okay? Knowing that, we need to solve for the voltage with Ohm's law, which is V is equal to the current in amps times resistance in ohms. So let's solve it. So V sub t is equal to I times R sub 1 plus I times R 2/3. So we get V sub t is equal to 2 amps times 500 ohms plus 2 amps times 172.4 ohms. So we get 1344.82 volts. And let's see if that checks out. Because, so right now we got the total voltage, right? And for the total voltage, it's equal to I, the amps, current in amps, times R sub t, which is the total resistance. So the total resistance is 500, right? No, I'm sorry, the total resistance is 672.41 ohms. And the total current is 2 amps, so V sub t is equal to 2A times the total resistance, which is 672.41 ohms. So we get 1344.82 volts, which you see highlighted on with italics in bold. So that's basically how you would compute combination circuits. And let's say you had R sub 4 and R sub 5. It'd be the same thing. You just have to add them together and create R sub 4 divided by 5, and like how you did with R sub 2 divided by 3. You could make very complex circuits and do this. Okay, thanks for watching my ACE 1000 KS 1975.